So when I was coming here, I had no idea what to talk about. But after, it's good that I am not the first person to talk about these things, because what Salil said and what Rama said, it really helped me to come to some points. So I will repeat certain things. Like Salil was saying, I also use board only. Slides only came up during lockdown, which has been helpful, because lots of things you draw and all these things take a lot of time. Some very long equations, etc. Sometimes actually its time is kind of wasted in those things. Now we can have more discussion because slides are there, but still most of the teaching is on board. So slides are only helping on those kind of things. So it's still blackboard teaching. So I like that. Technology wise, if something can be improved, I'm not sure. So another thing which I don't know what I did is special, and I never got department award, by the way. So I was really surprised, because usually it's a similar scoring technique. So it was really surprising that I got SP Sukhadme directly without getting department. But it's a 5-year average versus 10-year average. So maybe that was the reason. So assignments, what Rama was saying, that exactly same thing. I don't worry about cheating. Just keep the score low, 10% only for assignments. You discuss with yourselves whatever you do. Only thing is, it is not a photocopy. As long as that is maintained, that is fine with me, because it is for you to practice. It is helpful in your exam. So I'm not enforcing anything like that, because it is very difficult. If there is a 50 or 100 student class, how can you make sure that they are not cheating? So earlier weightage was higher. I just reduced it. I thought, you will do something, it is helpful for you, but it's up to you. So for assignments, that is the thing. So only thing which I think I did differently from what I used to do in the beginning, I have this computer projects in nuclear reactor theory class, which I am teaching. And when I was teaching heat transfer in earlier days, I had a computer project. Means 2 computer projects in both classes. So there was something like with what I was teaching. So nuclear reactor theory is the one course which I've been teaching for a long time. And power generation and systems planning. Power generation and systems planning has usually more than 70-80 students, and sometimes 140 also. Nuclear reactor theory, on the other hand, has only 30 or 40, and this time only 14, by the way. So it has reduced for some reason this semester. So large classes, I still cannot say that what you can do. My scores have been okay, but not very good in large classes, something like 80 to 90. Nuclear reactor theory, I always get close to 95% also many times. So in these type of courses where I have computer projects, so what I started, in the beginning what I realized, on the day it was due, the class attendance was 0. I think there was one girl actually who came. And the class before that also had 0 attendance. Reason? They were doing computer project. So I realized that the students don't get any time to do anything. They are very busy. So I made the computer project in class. So you come with your laptop. It will be a class on Saturday or Sunday or night 9 to 11. You come with your laptops. It's not that you have to finish the computer project and submit it here, but at least start in front of me, we can discuss. And that is the class where I have most interaction with the students, because I'm not teaching anything. I will just explain how to do it. Then I will move around, and then they ask questions and I explain how to do it. And that is really fun. Students like it, at least I hope they like it. And I also like it. So that is one thing which I have done differently. Second thing which I would say kind of may have some effect, like this nuclear reactor theory course, there was, in feedback, there was always this comment that it's a very theoretical course. There is not much about reactors as such. So I said, read that. There is a theory written there, nuclear reactor theory. So in the class, the class outline slides, which I have in the beginning, I started explaining what I'm going to teach. So I did not change anything in the syllabus. Only thing I did, I started explaining to the students that why we are teaching this, why this particular course doesn't have too much about reactors and more about theory of neutron diffusion, transport, etc. Because that is what this course entails, and why we are doing it, because it builds up how do you design reactors at the later part, or all those things. But we are not going to talk about reactors. So instead of changing the syllabus, because the course is based on certain things, I just started explaining it. So these kind of things may have helped. Another thing in exams, actually, I usually try to be confined to whatever I give in assignments. I don't want to give a question where students, it's like not like JE, that you are challenging students. I don't want to challenge. Whatever I'm teaching, if they know that, that is sufficient for me. Means my expectation is whatever I have done in the class, whatever I have done in the assignments, that much they should know. I don't want anything beyond that. No questions where you have challenged. So obviously there are still students who will do very well. There are still students who will do very poorly, but only because they have not done what I have taught them. So that I have made sure. Means sometimes it happens that you are thinking about something and questions become challenging. But most of the time I try to be confined to whatever I have taught. Because my idea is this is not a competition. It's not JE that there are 2 marks difference will make a huge deal. Everyone can get A, everyone can get whatever grade they want. If 10 students get A square, fine. I don't have any problem. I declare in the beginning of the course that this is the cutoff. If you cross that, you are definitely going to get A square. If you cross this, you are definitely going to get AB, irrespective of what other person is getting. Only thing is, if I feel like that paper has been somewhat tough, I may reduce it, but I will never increase because I have declared it. So I tell in the beginning itself that 85 plus is A square, then it remains 85 plus. It may go to 82 depending on performance and paper and all that, but I never do relative grading, especially in smaller classes. It doesn't make any sense. There are 15 students, what relative means. So, and then different courses have different spectrum also, like in case of larger classes, obviously it will be a distribution. In nuclear reactor theory, what I'm saying is that there is a clubbing at A square and then on lower side. So, because it's a straightforward questions. So if you do everything, you will most probably get A, B. And if you don't come to class and you don't do anything, you will get BC, CC kind of thing. In between, BB is actually rare. Usually, you'll see peak at BB. But in this kind of courses where small classes are there, actually my peak is on the ends. So that is very interesting. But I think the only reason is that whoever does it regularly and properly, they get very good grades. And whoever is not doing it will not get good grades. So now, any questions? That is what I had to say. Yeah.
So, leaving the numbers aside, in the feedback that the students submit, there is a comment section.
Comment section.
So, can you tell us one comment that has helped you? It seems that they had expected differently from your course. Yes. Any other comments which you got, which is a student written comment that helped you improve your either mode of delivery or content or anything?
I don't remember any comments, but I try to, every time I teach, I always think that whether I have been able to convey properly. So I keep thinking about it. That is one thing. Instead of just going to slides, many times I'm just even while doing something else or some other thing, I always have this thing that how can I teach this thing? Not necessarily my course also, in general also. If I'm even reading something, my tendency is to think about that. If I have to explain it to someone, how can I do? So I think that may have helped to some extent, but only students can comment on that because there is no feedback for this. But there have been some funny comments. That is very, very interesting. So one was that this class is very good for sleeping. Professor speaks in a tone where I can sleep very well. So that was very beginning of the semester. And recently, I think not very recent actually, 4 or 5 years back, one person said that exams and what has been taught has no relation with each other. But I may not know because I have never attended any class. So basically he said exams are irrelevant and they are not related to the course. But in the end he also said that he did not attend the class. So that is the thing. That comment I already talked about, that nuclear reactor theory course, there were lots of comments because students in nuclear reactor, and then they start thinking that it's something either with nuclear, something to do with nuclear physics, or something to do with reactors as such, means the structure of reactors and all. And it's a theory course. Unfortunately, there is no nuclear physics in it. Reactor theory is very different from nuclear physics. We are talking about neutron transport and diffusion and those kind of things. Statics, basically it should be called reactor statics and dynamics. But nuclear has to be there, otherwise reactor, there are many other types of reactors. but it's a very different course from nuclear physics. So expectations many times are very different. So sometimes names may not really convey what is being taught. So even power generation and systems planning can be anything actually just from the name. So those kind of things sometimes create problem when you start teaching and then the students are expecting something else. You go in a different mode. So beginning itself, I have slides. So I have slides like what this course is about and what this course is not about. So in elective that is okay because then whoever is not interested can leave. But core courses, you don't have that choice that if you don't like it, you leave. You still have to do it. So there is another problem how to teach a core course versus an elective. Elective, you can be more focused, you can identify these things. Students, only if they're interested, they can come and then you can tell them also if you're not interested, please leave. But core courses have to be taught differently because then you have to keep a level where everyone is okay and happy with it because otherwise it is a problem.
So, what is the attendance policy that you follow?
I don't have any.
So, don't take attendance?
No, I don't take attendance at all. My statement is this, in many classes I make, you are paying the fees. If I don't come, you should think about it. If you don't come, why should I worry? Right? You are paying, it's your gain. So only thing is that your assignments are related to the exam problems. So even if you are not coming to the class and you are able to do the assignment, I am okay with that. Because I don't believe that everything which I am teaching cannot be learned in other ways. Nowadays there are online things and I give links also for YouTube videos, etc. Not for nuclear reactor theory course because it's very fundamental and it's coming from 70s and all that. So, but for this power generation and systems planning, I keep giving links for YouTube videos, lectures from other places and all these things. So if they can learn from these YouTube videos and other things and everything and they are doing well in exam, I don't bother. So assignments, if you are doing all the assignments properly and if you are able to do without anybody's help, it's great actually. Why you have to come in the class and listen to everything if you can do it by yourself? And reason being that when I was a student, especially BTech, my attendance used to be very poor, by the way. So my attendance was 100% during MTech and PhD courses. So I feel that if you are not feeling that you are gaining something, just forcing you to come to the class and sit in the back and chat with other people and do WhatsApp and all this, it's not really helpful. So there are always a few students which never show up kind of thing also. And one or two of them will do very well also, by the way. It's not that all the students who are not coming to the class will not do well. Yeah, most of the time it is true that if you are coming to the class doing assignments regularly, you will do well. But I have seen students who are not coming to the class and they're still doing well. Sometimes it is only because they have done a similar course somewhere else, especially in power generation and systems planning, because there is some part which is done in mechanical engineering also. But it is unfortunate, but you cannot have a complete syllabus in such a way that there is no overlap with everything else. Especially in a core course because our own department students are there and some other students are taking it as elective.
So when you teach the core courses, there is a well-defined syllabus which one is expected to cover. So how often do you find yourself covering the full syllabus? Or?
Not many times actually, especially the course I was talking about, power generation and systems planning. If you read its syllabus, most probably it will take more than 2 semesters. Maybe we should redefine the syllabus itself because it's a very vast thing. So I try to cover most of the things. That is what I said, wide and less deep. So just touch upon everything. Only thing, when I started teaching this course, I have taught it for 6-7 times now. Usually after 3 years we change, but for some reason nobody else is willing to take it. So I taught it some 6-7 times now. So earlier there was main problem, I was not able to connect everything. It seemed like that different modules and they are not dependent on each other. Then I redid everything. So I started with economics first, and then I started relating everything to economics. Even when I'm teaching thermodynamics, I will say that this will increase your operational cost, this will increase your capital cost. So if you increase the efficiency, usually your operational cost goes down, but your capital cost will go up because you have to add something. And then specific examples that if this is there. So those kind of relationships I'm able to, at least to some extent, relate the whole, now it looks like one course. First time I taught it, it felt like I'm teaching 3 weeks of one course, then 3 weeks of another course, and 3 weeks of another course, because it was very new to me also, because it's a very wide course. So I think nobody in department, when they join, will be able to do justice to every topic. Because if you are from mechanical engineering, you may do thermodynamics well, but what about optimization issues, economic dispatch, which is coming from electrical? So it's a very vast subject. So it took me time to actually organize it properly in a way where I felt satisfactory. Now it is one course kind of thing, and everything kind of builds up one from the other.
So in the feedback, did you face a comment where student is saying that, oh, the professor has not taught the full syllabus or something?
Not really, because I asked many times the student this question. They are not aware what is in the syllabus. They just show up.
I think students are coherence better. What you just said, that's a fantastic strategy to me, you know. It's like you take something like economics, which is very important to everyone, right? And connect
Yeah.
your mechanical concepts, electrical concepts. and
Yeah, because power generation systems planning is actually about economics in the end. So you start, so I used to do it in the end, then I realized it's not working out. So I started with economics, basic economics, then I started relating it to everything which I am going to say. Because I said that systems planning is basically to reduce cost, right? So it's an optimization problem and cost optimization problem. So that is how I built this course finally in that structured way. But nobody said that, because I asked actually this question, not in some course, I don't remember exactly when, that I may not be doing this, and are you aware that this is written in the syllabus? Then I realized the students have no awareness. They never look. I am not saying 100% this is true, but most of the students don't look at the syllabus. They usually check with other students that how that person is teaching, what they are teaching. So there may be few students who look at the complete syllabus, but I'm kind of doubtful that there are many.
Okay, thanks.
Can I ask?
Yeah.
Yeah.
We are just coming out of this thing that you said that you've taken the course 6-7 times. Now, I'm from IDC, so our courses are quite different from
Regular,
the courses that you all teach. And I found that it took me 3 years to make that sort of
Structure, yeah.
structure. So I'm wondering the logic of changing the instructor after 3 years in many of the departments.
Our department has, it's just happened that I taught this in the beginning, then I had some gap, I again taught it, and now I have been teaching. Now I'm not teaching it because I had to teach first year those history courses, that
So
history
in
of...
our department, for example, our faculty has certain specializations. So even within animation, core faculty has different way of looking at animation. So it's very difficult for one faculty to teach what another faculty is teaching. So we tend to stick with the course for a longer time. And it has helped the way all the components sort of come together. And so each year is sort of a refinement of how to teach. So
Especially this wider... Yeah, so especially these wider courses. So for example, nuclear reactor theory, anywhere in the world you go, structure is almost similar. Means there may be changes.
Yeah,
but
the teaching component is
yeah, so it is similar. But when you go to this something like power generation systems planning I was talking about, where it is a vast syllabus, there is no structured way of teaching it. So there this challenge actually comes. So I think this policy that every 3 years is mostly coming from these fundamental types of courses, because heat transfer, most probably everyone will have the same topics. Order may slightly change, but I can comment.
Especially for big departments like mechanical, where you have 60 people, right? I mean, one person teaching a course for more than 3, 4, 5 years, then basically you're denying someone else to teach that course. So let's say there's a senior faculty.
Is there at least a handover process where, see, the content is fine.
Right.
Anybody can teach content.
Right.
But when I'm teaching a new course, how the students are receiving it, you sort of learn, like first year,
Agreed.
you sort of.
I
So,
completely
is there a handover that, okay, this is the way to teach, or there's some process?
No, we don't have a formal process.
I don't think there's a formal process, but invariably when I'm asked to teach a new course, I will go and consult the faculty who taught that course for the past 2-3 years and find out from that person, okay, what topics he or she covered and which topics students were able to absorb and which topics the students found it more difficult to absorb. So these conversations take place almost without fail, and so that handover process, it works informally.
To answer your question, see, if you're teaching, let's say I'm teaching an elective. I mean, I work in, let's say, that's my area of research. It's very rare that someone else is going to come and say that I want to teach that course. This 3-year thing with business primarily occurs when you're teaching core courses, undergrad core courses. So that is where we have that.
And then there is some kind of universality in that course, that everywhere there is a structure which is similar. A problem comes in departments like ours, where there is a core course which is not non-standard. So for example, mechanical engineering heat transfer, let's say heat transfer course. Obviously there are differences how people teach it, but usually there are things which you have to teach, right? This is heat transfer, these are the conduction, convection, this kind of things. Even nuclear reactor theory, which is an elective, but still, because in many places it's a core course where nuclear engineering departments are there. So there are structures. There it is kind of handing over may not be a difficult thing. But in our department, which is highly interdisciplinary, a course like energy management or power generation systems planning, these are kind of non-standard courses. None of us, at least most of us, have not even seen the syllabus before joining here. And it is a core course. So it's not like I will be teaching whatever I have learned from there. So there, this issue, what you are saying, comes actually, maybe it is helpful if there is a longer time. Because first time you are teaching energy management, you take lots of effort to understand what is going on. And after 3 years, if you have to give up, by that time actually you are kind of getting sure that this is what needs to be taught. So I should say non-standard core courses, this kind of thing may be. Elective, obviously, you have your own elective. Most probably you are going to teach it for a long time. And standard core courses like thermodynamics or heat transfer or even nuclear reactor theory, the syllabus is kind of universally defined. May not be exactly same, but very similar.
So
But yes, I agree.
Time in the end to circle back to larger questions of larger interest. Okay, let's just hear from the
No,
other
that was
two.
basically because he said he thought it must have been.
Absolutely.